Okay, so welcome everyone. Thank you for joining this session today. My name is Daniela. This is Romina Druta. Uh, we are from Visma. We work in Visma. And I'm also a professor at NTNU, but we will talk a little bit about that. Just to start, our talk is called Maximizing Security with Threat Modeling for the Cloud. As a disclaimer, just to start with, we are not claiming that we found the best or the only way to do threat modeling, but it's the way that we found that is working for us. So it's based on our experiences in Visma, also my experience as a professor at NDNU, doing different types of research in threat modeling, and our results that we have. So then it's not like the only way, or like the most effective way, but it's the way that we are thinking, that we find that it works for us in our context. So then we will talk a little bit. I hope you enjoyed the presentation today. Just a little bit about me. I'm now on kind of a life crisis maybe, because I'm a professor at NTNU until December this year, and last year. And then this year, I'm trying a new job, so I'm 100% CISO in Visma. So if by the end of the year, I have to decide if I will continue back as a professor or in Visma. So if you search me online, you will find I'm having two positions because of that. I'm also previously a researcher in SINTEF. I worked in SINTEF for 8 years. Also doing research in how to include agile security in agile software development and agile practices. And that is how we started my journey with Visma. And I'll talk a little bit about that. As you see, my passion is for improvement. I always think that we can improve everything. As I say now in the presentation as well, we can always improve. As in my life also, I think that I can always improve with something. And I think that's why I'm always trying to learn new things and get new things done. Romina, maybe you can talk a little bit about yourself.
Hello everyone, I'm Romina. I'm a security service owner in Visma and a cloud security researcher. I'm also a PhD student and teaching assistant at the University Politehnica of Timișoara. I'm as well the cloud native lead for Timișoara and the KCD organizer, and I like to share knowledge and create communities so we can spread the knowledge and teach the others as well.
Good. Yeah, so a little bit about Visma. I'm not going to talk a lot about it, but we are now one of the top software companies in Europe. I don't know if many knows, but it's a Norwegian company. But now we have quite a lot of other companies around the world. We have been acquiring quite many software companies lately, and our focus is on ERP. We are one of the top in Europe in ERP systems. And we are ERP, HR, payments, invoices, and things like that. That is the focus of our companies. We are also leading in cloud software. We have more than 2,000 cloud operational accounts. So then that is also what motivated us to start looking a little bit more of how to be better security on the cloud. And then we had also our own software to try and then to also get knowledge about it. So just a little bit of the history for our Visma security program that we call Visma security program. Before it was called the Visma application security program. And the reason for that is because in 2016-17, we started seeing that companies were software companies in our niche was quite focused in the IT security, but the application security was not as well covered. So that was also how I started doing a little bit more security into Agile, because the software companies came to us in SINTEF and said, we have no idea how to do this security stuff, and keeping agile, keeping self-management teams, keeping the whole agility going and the process going in a way that we deliver software and not only think about security. And we also don't have money to pay all the security experts or to stop and wait for them to come and review our systems. And that was the first motivation when we started also in Visma, because Visma was also part of this project with SINTEF. Then we started this whole thing, and then our main goal was always to empower the teams to autonomously manage their security. So we didn't want to create a program that the companies would have to stop and wait for a security expert to come to them and say, now you can go, or now it's okay to deploy, now it's okay to go for production, and things like that. We also believed that every day, developers and people in the teams are taking decisions. And these decisions have to take in a secure way. So we cannot just think that we are going to have someone almighty to come and say, now you're good in security. We have to trust that everyone in the teams knows what they are doing and know how they're handling security in a good way. So that was how we started. And then then this is basically just the part that we focus on the application, that we do what we call services. We have the Visma group that provides services to the teams for them to be able to manage and out-management security in a good way. So what we do is that we require for the companies to do every year a self-assessment of their security. It's like a security review of their system and what they are doing in the application level. I'll talk about this, but I would claim that is a threat analysis of the system, but some people may challenge this definition. And then we also have a data protection self-assessment in which the teams goes and evaluate how is their posture towards data protection. We also ask a pen test from Visma once a year. So then this is kind of 3 annual assessments that we ask each one of the teams to do. We also have 2 tools that we ask to be integrated in the pipeline. One is the static analysis tools, and then a software composition analysis. 2 monitoring services that we do in our own systems to monitor how the domains are being mentioned in the dark web and the different dumps of repositories and things like that, so then we can protect our software companies as well. And we have 2 external ethical hacking services, that is a bug bounty and a responsible disclosure. Does it mean that they only do this? No. But this is the minimum requirement that we say for you to be still part of the Visma family, you have to comply with. So the teams have to find how they are going to do it. Of course, we have the provision of all the tools. We don't make them pay for the licenses. We pay for the licenses, but they have to use it. And we do monitoring and gamification and all the things about that. So, but then what was missing? This was an application level, right? So then what happened was that many times, and I always still do that, but many times the teams also wanted to do an extra modeling of the threats, or finding out what else they could find that was not coded, or that you couldn't find with an automatic tool. Then we started doing manual threat modeling with the applications, and then we just but that was not part of the program because it's not something that we could scale and say, 270 companies, you have to do this. So, and also we didn't find an automated way to do a good process of threat modeling. Then we just do that by demand when the teams are changing the system, when they have a big change in the architecture, or when they have they are not really sure how their posture to security is. There are many different ways that it triggers a threat modeling, and then we do by demand to them. But then what started to happen was that then I started, as the company started moving to the cloud, I didn't have a good process to say, okay, I also have confidence that we are also checking all the threats that you have to deal with for the cloud. And that's what motivated the work that we have done. We started looking at what is it that we also have to check when we talk about threat modeling in the cloud. So we knew that there were possible vulnerabilities, general things that people talked about, but we didn't want to be in the level of just okay, do you have possible exposed assets with open port? That was too weak for us, because this we could just ask, right, and then ask everyone to check, and that was fine. But that doesn't work like that. That meant that we needed a process that also was not overwhelming for the teams in a way that they would check everything that there is about cloud to think if it is okay. But we needed also to be concrete about what are the problems that we had in-house that then we have low maturity or low awareness, so then all the teams have to get better on it. Our idea is always to get the teams in Visma on a level of maturity that is kind of, it doesn't go up and down, but all the teams have more or less the same level of maturity. Yeah, so then we come to the threat modeling. So as I said, I'm a professor, so then I have to say about definitions. Some people, there are different definitions of what is a threat modeling. There are different ways of seeing threat modeling, and there are different ways of doing threat modeling. There are schools of like the way that you should do, how you should do, how deep it should be, how systematic it should be, and everything else. And also there is a thing about when you could call it a threat modeling. So some says that you can only call threat modeling if it's made up to the design phase, because then it's not yet in production. It's not yet implemented, so then you still have a possibility to change design as you wish, right? But do you think that we managed to do that with nowadays pace of development, to stop and say, okay, now you can check before we go ahead? No. So then that is why some people would call threat analysis what we do here, because we don't stop production, or we don't stop like the development to then do an analysis, but we do as we go, and then we try to find the threats, and then we try to fix those as it goes, right? So some people, especially online, would say this is not threat modeling, but I would say that it's threat modeling and it's threat analysis. I will use calling threat modeling. But basically, threat modeling, it's a process that reviews the security of any system, identifying problem areas, and determine risks associated with each area. We, and I like that more, but I used, like, for a long time, the Microsoft approach to threat modeling. And that's my favorite approach, and that's the one that we use it here. But like I said, there are many other ways to do threat modeling. You can do attack trees, you can do use case diagrams, misuse case diagrams. You can really, there is really a lot of different ways to do. And like my way, or the way that we are doing in Visma, is based on the Microsoft threat modeling. That was like proposed in 2004 or something, long time ago. There is a big book about it. It's still very actual, and it's still very useful to who wants to start doing threat modeling. And what they do is what they call an asset-centric approach. That is to think of, like, you think of your attackers and who could attack your system. Then you have to go down to concretely think of your assets and what are the assets that it's important for your system. So then you don't go all over the place, but you focus on what could be something that could harm your company or your system or your software and so on. So then after that, you look at these assets and think, how they can be exploited? That is the attack surface, right? So then what is it that makes this asset exploitable? What is it that we didn't put in place that makes this asset exploitable? And then you do follow-up actions. That's not the easy part, but I'll talk about that afterwards. So the first thing that Microsoft threat modeling approach says, it's like think like an attacker. But thinking like an attacker, it's very hard. And it's hard for the developers because most of the developers, they were built to kind of think of how we want this system to work, not how we want the system to not work. Or we don't have this like mindset of like we want to hack everything and abuse of the systems, right? So then this mindset is very hard to kind of put in place. And then we have to start making exercises of thinking concretely who we could think that could harm us, right? So then we have to identify who do we think that they are, and also then we can identify how capable they are to attack us, and what is it also that they are interested in. Some, and I'm not going to talk about all different types, but some of the types of attackers can be, for example, state-sponsored actors. So Maybe there is one country that wants to find a way to harm another country, and then they hire people to really try to find a way to stop some services, for example, electrical systems, or they want to stop the transportation systems in a specific city, or different things that they want to do, right? So then that could be something that could be state-sponsored attacks or actors, and usually they have lots of resources. So they are targeted. They know what they want. They know which country they want to go for, and then they just put all the resources there. Then the possibilities are infinite. Like thinking what they can do, it's almost impossible because it's really a lot of people with a lot of knowledge and really driving to just focus on that focus. The hacktivists are the ones that have an ideological reason for harming a certain system, right? So then they think like, okay, there was a case in US of a website that was about like cheating and things like that, and then the hacker said to them, if you don't put the system down, we are going to take you down. Then they gave warnings, and then they said, here's the proof that we have everything it takes for us to put it down. Will you put it down? No, we're not going to put it down. There was no financial gain behind it. There was nothing behind it. The only thing is that the hacktivists didn't agree with the model of the website. And then they said to them, they said, no one did anything, no one believed, but then they put down the whole system and then took, I think everyone knows about all the data that is dumped and all the, there is even a Netflix on this, a Netflix video. So hacktivists, they are also more targeted because they want you. They don't want everyone. They don't want anyone. They want that specific system. And they are going to try it as much as they can to try to get that what they want about the system. And then it comes the career cyber criminals. That is the one that we in Visma would say that we are mostly worried about, because these are the ones that are losing for financial gains. They want to get money. They want to kind of exploit the invoices so then they can get the invoices to their own accounts, right? Or they want to find a way that they can make money with the data that they can get out of Visma, or like ERP systems and things like that. So these ones are also a special one because what we notice is that some of them are quite specialized, but usually they try to get in volume. So they are more worried about like, okay, where we can get the easy wins, so we make more money in volume, right? Of course, if they find a possibility that they're going to make a lot of money in one system, they're going to also invest on that. And then there are the insiders. So you all work in software companies. Do you think, who thinks that you are an insider in a company? So the rest, you don't think you are insiders. We are all insiders. So even I am an insider. I can be not really willing to harm Visma, but maybe I make a mistake. And because like I have knowledge and I have more access than other people would have, I could harm Visma because of like maybe a behavior that I didn't really think that it was wrong, or maybe something that I did that exposed my password, or things like that. So all of us, we are. But we can be malicious insiders. Maybe not we are going to be, but I hope not. But it can be also that someone, because of motivation or because of like, we don't know when, can just decide that like, okay, now I know so much and I can do a harm, so then I will do. Because they have much more information than other people would have. So one of the main things that we work a lot in Visma, it's about like need to know basis. Like it's not because we are developers in a software company that we have to have access to everything in production, or that we have to have access of like how to do anything we want, all the types of keys, all the secrets and everything. We don't need that, right? So we can all be insiders, and insiders is also one of our important points. It's like, it's also one of the reasons that we look at mini configurations in the cloud as well. Because we have to be aware that like we may create problems to our own company. So it's better to not be able to do that. So you feel much better about that. So sometimes in Visma I say, I prefer not to have access to this part here, because then at least I know that I don't have access, right? So yeah, so then when we identify the attackers' impact, so I said already a lot about this already, but then 3 main things are important that they are looking for. One is to harm confidentiality, get data that should be kept in secret, but put it in the open. Integrity, many times change just the integrity. Many attacks happen by changing integrity of data little by little. And then just unnoticed for years until they just like, for example, now with AI, that is one of the main things that we have. We can just change little by little the inputs, right? We will never know. That is poisoning the data just little by little. And then the time comes that then they use it to activate what they want, right? Availability, of course, we are in a society that everything should be there 100% of the time. We want people to be able to use our systems 100% of the time. So then availability is also one of the targets. Of course, what the boards always think is like, what is it to make financial losses for us? And of course, we need to think about that. Many times, all this, the impact will in the end get to financial losses. So, of course, there are other ones of privacy and everything else. We also worry about that when we talk about confidentiality. But we also worry a lot about how we are going to do this because of the type of business that we do. So, the next phase, it's the identify your assets. And that is where it starts to be different for the cloud. So then that's why Romina is here.
Okay, so from here, it will be a lot more technical. How many of you are using public cloud? Okay, most of you, it's okay. So, what the hackers would like to identify, or now, so far you saw who are the attackers, so now you should see what are the assets that they are interested in. In the cloud, most of the assets are related to compute services like virtual machines, applications, functions, Lambda functions in AWS, Azure functions in Azure. Then you have the databases and storages where you store your data, your users and groups that are as well assets. If a user is compromised, you might have surprises. And of course, your network. It's important as well in the cloud, because if an attacker get access to it, he can do lateral movements, and then he can get to other important resources that you have there. So after you know what are the assets, you have to see how you can be attacked and how those assets can be impacted. And one way to find this is to find the attack surface, meaning that you have to find the entry points that an attacker might use to get to your resources. And here we have a cloud ransomware attack. It's just an example. So for example, we can say that we have an exposed and misconfigured cloud resource, like a virtual machine that has open SSH or RDP ports. And then you have an attacker that is performing some brute force attacks. And then you have a user admin and password, so he can get into it. And just imagine that he can install some vulnerabilities on your VM. And in the case that you are using that virtual machine for deployments, meaning that you are using, you have some GitHub actions running on it, then your attacker can get to deploy code on your web apps or your Kubernetes clusters, and he can gain access to your data from that web app or Kubernetes cluster. From there, he can do data exfiltration, and he can even re-encrypt the data with the keys that he wants, and then later ask for a ransom. So this is just one of the examples of an asset being publicly exposed, but just imagine that there are multiple ways that an asset can be attacked. And you can do like attack trees to see different ways of your resources being misconfigured. But we did not want to get lost with a lot of different ways we can get attacked, and we wanted something more centric. That's why we looked to the most common vulnerabilities in our cloud accounts. And last year, we did a proof of concept with some cloud-native application protection platforms, tools, like UI Security, Aqua Security, Orca Security. Those are the cloud-native application protection platforms that are scanning your cloud environments for misconfiguration, vulnerabilities, and other type of misconfigurations. And we saw that there are some compliance framework there, and one of them was Mitre. How many of you heard about Mitre attack framework? Okay. So Mitre attack framework, it's a framework that has a lot of different tactics that an attacker can use to gain access into your system and then damage it. So what we did, we applied this Mitre compliance framework, and we grouped the assets that we had in the cloud by their type, meaning if they were compute services, database services, users, and so on. And down you have the Mitre attack tactics, which were like initial access, execution, privilege escalation. We will speak about each one later. And then based on the results that we had, we extracted some questions that we wanted to use in our threat modeling sessions with the stride LM, stride lateral movement method. How many of you know about stride? Okay, good. I will explain it later. But I was told that this is like a common method to do threat modeling. It's more like easier than Mitre attack framework, because Mitre attack has a lot of tactics and a lot of methods that an attacker can use, and then you can get a little bit lost. So if you want to do a threat modeling session, maybe it's better to start with stride first. But how we arrived from Mitre to stride, it was that we applied this Mitre framework to know what an attacker can use to gain access into our system, and what are the issues or misconfigurations that we can prevent and we can make aware our engineers to avoid in order not to get compromised systems. So, like I said, we categorize the findings, and those are the attack tactics used by the Mitre attack cloud metrics. What we have found in our system were all the yellow tactics. So the most of the findings were related to the yellow tactics, like initial access, where an attacker gets access into your system. Execution and persistent, we did not have so many findings. Then privilege escalation, where an attacker can make use of some IAM policies, identity and access management policies, that are not correctly configured, and then they can elevate their permissions. Then defense evasion, where the attacker can get a notice. Then credential access, where the attacker wants to steal the credentials. Discovery, the attacker wants to get to know your resources and your network of resources, your cloud infrastructure in other way. Lateral movement, and how an attacker can move from one resource to another in your environment. Collection, where the attacker gets the data, it collects the data, then it can exfiltrate this data, and then, of course, there might be also an impact that you will have in your cloud system. If you have not backed up your data or encrypt the data, you might lose it. So, initial access. Like I said, the attackers want first to get access to your cloud environment. And the findings that we had, like I said, we were vulnerable to this attack method, were a lot of public virtual machine exposed with open ports, the one we did example before. Then, not surprisingly, because this is like known that 80% or 90% last year or 2 years ago of control plane Kubernetes APIs were publicly exposed. And it's really easy, if you get access to the control plane, it's really easy to do damage on your nodes, on your application pods. So your system might not act like you would wish if an attacker gets control of the Kubernetes API. Then there were a lot of misconfigurations related to application services that were not having authentication configurations on. And there were as well some web server configuration exposed. If you have an HTTPD configuration file exposed with user and passwords, yeah, you are in danger that someone will get access to your system. The privilege escalation tactic, to this tactic, we were like in danger because we found a lot of IAM users and roles with privilege, with administrative privilege, and also service accounts with administrative privilege. When I'm saying service accounts, meaning that a deployment user or the user used by your application was having owner rights on the subscription or editor rights on the subscription, on your cloud subscription. So if your service account is taken away, then again, you might get some problems there. For defense evasion is when the attacker will think that he won't be detected, to say like that. So, and this is possible for the intruders as well. If the auditing logs are disabled and key vault, so if someone is doing actions on the resource where you are storing the secrets or on your storage accounts, you cannot catch it, or you cannot determine an anomaly if you don't have logs to see what is happening there. Most of the teams are not like enabling this because due to the costs, or due to maybe integrations with other systems, and maybe due to the fact that it's hard to analyze. But if you don't have those enabled, you might, if you get compromised, you won't be able to see from where it started, your breach in your system, and who is impacted and who is not impacted. The adversary wants as well to steal the credential access, so the vulnerabilities that we had in our system were, again, related to users without MFAs. And we did not, the possibility of the sniffing in the network, because there was no HTTPS enforcement on the storage account. So the storage account could be accessed without HTTPS. Discovery starts, again, if you have the publicly exposed virtual machine, but not only virtual machines. You can have your database exposed, you can have network security misconfigured, and you can as well, if you don't use firewalls to block access to your network, for an adversary it will be easier to see what you have in your system. Lateral movement, it's the way that an attacker will try to move through network. And for example, if you have a Kubernetes cluster and your namespaces don't have a network policy defined for each namespace, then the attacker can move from one namespace to another. Also, there were controllers, Kubernetes controller creating container with secrets as environment variables, and this can be, if they are not set as a secret, they can be fetched easily from Kubernetes clusters. Okay, now when we arrive to collection, the vulnerabilities that we had were related to storage container publicly exposed. So for an attacker, it will be easier to fetch the data if if the data is not anonymized or not encrypted with customer managed key. Or imagine if there is an account, a user account that has access on a storage account or on an S3 bucket, and then these users get compromised, then the data will be available for the attacker in case if this data is not encrypted with customer managed key. So if you rely on encrypting your data with the keys by default provided by the cloud providers, it's like it's secure, but not so secure. So you should use customer managed key to have an extra layer of security. And for the exfiltration, we found a lot of misconfiguration related to networking, no outbound rules. So everyone can transfer from our network, firewall bypass by cloud provider services. For example, it happens to the database in Azure or on a key vault in Azure to allow all the other Azure services to have access to those resources. So imagine that you have a VM that belongs to a user, but it is still in Azure, and then you allow access to your database from any Azure services, so this VM will have as well access to your database. It's only because it is in Azure. And then what could be the impact that the adversary will try to have in your infrastructure? The impact, so you are doomed to impact, to say like that, if you don't have deletion protection in place for key vaults. So you can prevent the impact by setting deletion protection for storages, key vaults, by having backups in place for your databases, and by setting locks on your resources. Because if an attacker gets in, he can delete the data, but if you have some protection, extra protection in place, then you can find your data later. So those were the attack tactics from Mitre, for which we found vulnerabilities in our systems. And with those findings, we went to Stride, which is another method to do threat modeling. Stride comes from, it's an acronym from spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. And those were 6 methods used usually by engineers for applications and in development to do threat modeling. But some engineer practitioners from Lockheed saw the need for applying Stride for networks as well. That's why they came with lateral movement, the ability of an attacker to move inside the network. So what is spoofing? The spoofing is a way by which an attacker tries to impersonate himself. And how you can prevent the spoofing in your cloud environment is by whitelisting the IPs and for your publicly exposed resources. So you know that only the trusted IPs have access to your resources. And if an attacker impersonates and tries to access your resources from another IP, he won't have access to it. What is different from on-premise is that on-premise were a lot of spoofing acts at the networking level, but in the cloud it's a little bit different, because here spoofing, because having a greater attack surface and having the services using APIs, the attacker will try to do an API spoofing or an identity and access management spoofing. So if you want to prevent this, you should ask yourself if you have firewalls and security groups in place, if you have rate limit and geo-blocking access, meaning if you are not serving a specific, your application is not serving United States, for example, just cut the IPs coming from the United States. Tampering is the way that we want the attacker will want to modify or the data or your code, and the way that you can prevent this is to ensure that you have all the data encrypted in rest and in transit, and all the cloud storage will use TLS 1.2. This is something that it was introduced in the last 2 years, so the storages were using TLS 1.1. Microsoft came and the other cloud providers with TLS 1.2. But it might be that if you provision your infrastructure 4 years ago, you might be using just TLS 1.1. So just be sure that you are using TLS 1.2 and you change this configuration. Then you can enable file monitoring to detect change critical changes to your critical files. Try to use backup vaults. Those are some services provided by the cloud providers to back up your data and store it securely, and only certain persons have access there. And try to have logging and monitoring services enabled. Repudiation is the way that the attacker is trying to deny. He can deny some actions. For example, he will try to use to do transaction or document signing. So in another way. So you need to use digital signature for transactions and document signing. You need to perform regular audits for his access, and you need to have access logs and cloud audit logs in place to see when he is doing malicious actions in your system. For the information disclosure is when the attacker wants to gain access to your confidential information. So in order to prevent this, all your confidential information should be safe. So try to apply stricter controls on your sensitive data. Your sensitive data can be credit card information, personal identification information, healthcare information. Try to store this data on a different storage account than where all your data is. Then try to have security groups and access control lists in place. And for those storages that have sensitive data, try not to have public access to it. Try not to have them publicly exposed. For denial of service, it's the method that an attacker will use to disrupt your service. And here the questions that we would have asked the teams during a threat modeling session would have been around if they have DDoS protection services in place, like AVS Shield or Google Cloud Armor, or if they have web application firewalls in place, not only just to have a web application service, and then if there will be a lot of requests to this application service, the service might get down. As well, have some monitoring in place to detect from before if there will be increasing DDoS attacks for your application. And what is important here is to set limits. Because if you will have a DDoS attacks in the cloud, everything can scale. So if you have configured your application, your resources to scale, and you have a big DDoS attack, and there are no limits of scaling for your application, you might get a high cost. Of course, as well, there are some other limits to configure. In some regions, for example, you can use only 10 instances of virtual machines, for example. So if your application will scale until 10, and then there might be some problems, and the service can be disrupted. So you have to check as well on your cloud provider what are the limits, but then you have the minimum limits to scalability, but then you have to set as well a maximum limit to scalability for yourself. The last from Stride, it's the elevation of privileges. And here what we focused on was not to let the insider gain more privileges. And one way to do this, so if someone gets still into your network, you can avoid that he will have access to everything by employing segregation of duties, meaning just don't have one administrator that is in charge of everything. Try to have different duties for different people. So in case some accounts get breached, only some actions of that account might be impacted. Of course, least privilege access, it's important, and airbag roles. You should be aware and careful to the roles that you grant for your user. For example, if you grant a creation of an access policy on a keyboard, a user can, with that access policy, you say, okay, he can just create a policy, but he can create policies that will delete your secrets. And there are third-party tools that maybe need access to your Key Vault, and because they want to read some secrets there or metadata there. And by granting them this create policy, you will grant them as well indirectly rights to delete secrets there as well. So, arriving to lateral movement, which is the last from our stride LM, we can prevent the attackers to move inside our network by setting monitoring in place of the people who are accessing our resources, using Bastion or jump servers to configure our infrastructure, and using segmentation, network segmentation, so isolating the services in subnets. So in case a service gets compromised in a subnet, not all your network will be compromised. And what is as well new is the micro-segmentation, which is like the separation that will restrict the traffic flow between the resources. So those were the questions, the kind of questions that we thought to ask during a threat modeling session, but you can find other ways to derive questions. And one way is to use this CSF tool that will allow you to use the cloud control metrics, and you can find other questions that you can use during your threat modeling session. So what we do with the finding from threat modeling is that we follow up actions and awareness sessions with our teams to mitigate these threats internally. And of course, we try to prioritize them. What is the cost? What is the complexity versus the emergency and importance of the misconfiguration or of the findings. So now you know how to find the actors, the motivations, and the threat to your assets. Don't forget to put in place the follow-up actions. What is next for us in Visma is what we call a new Cloud Guardian service that will focus mostly now on the cloud. With the findings that we find, with the findings from the scanning process of all our cloud tenants, we want to get more automation in place and use those security findings in our threat modeling sessions. So in other words, we try to learn from the findings and then teach the others to avoid the vulnerabilities that we find. And maybe to automate the process, meaning that by finding the vulnerabilities, we can have something automatic in place that when we create like an infrastructure, imagine that you want to design a schema of your infrastructure, you just drag and drop your resource, and then the questions will pop up with, are you sure that is not exposed? Are you sure that is in a virtual network that is segmented? So the findings that we found from the scanning and during the process to be used at the beginning when we are creating our infrastructure system. Yeah, so that was our presentation. If you have questions, we are here. If not, thank you for your attendance.
I think we have time for questions. Any questions? Yeah.
I have a question. How did you make a balance between the developer productivity experience and also applying all these factors within organization, group, team, and at the same time satisfying the stakeholders that we want to deliver?
That is 1 million question. That is our main. These days, I was talking to one of the product owners, and then he said, we were asking him, what's your main challenge? And then he said, prioritization, right? So prioritization is the hardest part, you know, like knowing how to prioritize these things towards like functionalities and new functionalities and technical depth and all those things. That is something that we are working in Visma as well. We have another project that's with Syntef as well that is about technical depth management to try to understand what is it that we need to feed the product owners, the developers, and so on, so then they can prioritize in a best way, you know. But it's always kind of a different dialogue with each one of the companies I have, because they are in different stages, they have different experiences, they have different pressures. So we always have to do case a case and then try to do the best prioritization we can, you know. Security, at least in our context, we put a lot of pressure. So usually we put much more value to fixing security than the functionality, but it's not always the case. Yeah. So that is, I would say that like if the next, I had a PhD student that just finished it, just prioritizing security. We had a whole PhD and we didn't manage to answer that question. And I still want to do 2 or 3 more PhDs to get that answer. But it is hard. We have a whole model and theory and so on, but I can give you what we found so far, what makes prioritizing up and down and things like that. We started to understand, but we still don't have the answer. Sorry. Yeah. Yeah. Other questions? Yeah.
Some of the vulnerabilities that you mentioned, like the SSH port or the RDP ports are open, can't you just apply some policies in the cloud so that you don't allow resources to be created this way?
You can apply policies, but it's only that not all teams are applying the policies.
Yeah.
You can restrict from top, but what we try to do is we try to see the maturity of our cloud environment and what are the vulnerabilities that we have in it, so we know what to apply later. But this can be a follow-up action. So, good question.
And also another thing that is important in our context is that we are not a company that has, it's like we have 170 companies. So each one of them have their independency, right? So we cannot apply a policy that is just going to work, you know. They have to get this awareness and they have to apply the policies that we define as best practices. And that's what we try to do with the tools that we apply, you know, to kind of create this awareness of what should be applied. Yeah. But we don't like to work on policy-driven approach.
How do you enforce these things? Do you have like in every team or in every company representatives, some champions plan?
Yeah, so when a company is acquired by Visma, we always have a role of a security contact, security engineers in each one of the teams, and then we have a whole governance towards boards and board members and then everyone else to make sure that we have not only bottom-up, but also top-down approach to security. Yeah, and that is quite strong in Visma, come from the CEO to everyone. Yeah.
But it's not like we are trying to force the security. We try to convince the people to adopt the security. We try to explain them what is the importance. So it's their decision. It's not like something that we are forcing them. We are forcing in a way because then they don't have like a gold tier in security, but it has to come from them. They have first to understand that the security is important. Otherwise, it will be hard to do. If you're not convinced to do something, then it will be hard to do it.
Yeah, yeah. It's another talk, but we have a whole approach that we try to do that we call the ambidextrous security program, that we try to find this balance of not being too forceful, but also not being too loose, you know. So then trying to find this balance that we have both bottom-up decisions and top-down decisions that they can make. You can talk about that.
Okay, so we evaluated different cloud-native application protection tools to have more visibility in the cloud. Given that we are a multi-cloud company, we have Azure, AWS, and GCP. we wanted a tool that applies to all cloud providers, because otherwise it would have been difficult to see Azure Defender for Cloud or CloudWatch and so on. You want to know what we're evaluating in those tools, or?
Basically, which tools worked well and which didn't.
I don't know. I can say this.
Yeah,
but,
maybe we cannot, because we cannot make a commercial to other companies. But we can talk to you in private, and then we can tell you which ones we evaluated.
I can say only that no, they are mature. The tools that we evaluated are mature, so the tools that are on the market are mature, and it's a benefit in using them. So it gives you visibility, and it helps you to learn more about security in the cloud. There were differences in findings, I can say like that, but yeah, that's all that I can say.
But we can tell you later which ones we did. Yeah. Other questions? Yeah.
I know Visma is old company and you already have a lot of legacy applications and so how do you handle that security on just use?
Yeah, so that is like one of our challenges as well. We have lots of legacy applications. So then what we tried to do in this model also was like, for example, SaaS tools are easier to use. But for example, penetration testing is not so easy to do, right? So then we don't require the same to cloud native applications as we require to the on-prem. But then we also make sure that they have more monitoring and other things that they have to do themselves. And especially like when we talk about the program, that doesn't mean that is all they have to do. Each company have to decide what they have to do to make sure they are secure. This is the minimum that we can have visibility about how the posture is, you know, but it's not all they do. Yeah. So with the on-prem, they have different approaches than with the cloud. Yes. But also it's less exposure, less number of, yeah. So there are different techniques that we use there. But it is challenging, especially like new services like the Cloud Guardian, they will not be onboarded. The Pentest, they are not onboarded. The Dash, they are not onboarded. So some of the things we just say, okay, it's not applicable because we cannot do that. Yeah. And also, sometimes they have quite a lot of risk that we cannot fix. So we can only mitigate, not fix, because we even don't have the coding anymore or something.
There is one more question in the back.
Yeah?
How do you adapt the Visma security program legislation like DORA? And do you use the program to carry you through the legislation?
Yes. So, do you want to say? Okay. So, for the DORA, for example, because this is only the application part, we also have what we call the Visma Infrastructure Security Program, and then we have the Visma People Security Program and the Visma Solutions Program. So these different types of program, they complement to the requirements that DORA has, for example. So every time a new legislation comes, what we do is that we make an analysis to see what is it that is missing in our program that we have to make sure that the companies are doing themselves. Yeah. So we have another type, and we also have the legal program that is also part of checking this part. So for DORA, for example, we did an evaluation, and then if you are following the VASP and the VISP, you are basically covered for the DORA, for example.
For the cloud native application protection, they have a DORA compliance framework with, I don't know, 1,000, 2,000 controls. So if you just scan using the DORA compliance framework, you can find what you are compliant with for your cloud account and what you are not. So the teams, I think this will be a new service maybe, so the teams know how they can be compliant with. So this is another way to do it easier. It's like the framework is already defined. But this is only for the cloud.
Does it answer your question? Maybe not.
It creates whole new ones. I'm very curious how you scan Azure resources and check if they are compliant with DORA. But that's a whole doctor thesis.
I did not scan them, but I only saw that there is a compliance framework for DORA, and it has a lot of controls there.
Another question? Or it's our time now?
Yeah, it's like you have one more minute to ask questions if you wish, but if not.
Any other questions? Or okay. So thank you for attending. And if you have any questions, we can talk afterwards, and you can also contact us. And we will try to answer as much as we can or we know about it. So thank you.
Thank you.